All right, hi. We're going to talk about the mole today, and the mole is it's kind of a complicated concept sometimes. Um, I'm going to try to explain it as best I can. Simply, there's some videos on the Canvas website to watch as well, um, and yeah, hopefully from that you'll get the basic idea. Now, the simple version is that if you talk about the mole, simplest way to look at it is instead thinking about it in terms of like if I tell you that you have a dozen of something, if I say you have 1 dozen of something, you know that equals 12 of something. If I say you have 1 pair of something, you know that equals two, whatever it might be. And it doesn't matter. You can have you can have 1 dozen eggs. That equals 12 eggs, right? We get that. At the same time, you could have 1 dozen turkeys, because who doesn't want a dozen turkeys? And that will also equal 12 turkeys. You can have a dozen morons, then you'll have 12 morons, like whatever. It's all the same, right? It's all relative. So, um, the basic idea behind doing this is that the idea of a dozen, it's something where it can represent anything. It can represent any quantity that you might have. You can have a dozen computers, a dozen eggs, a dozen whatever. Same thing is in place for the mole. Now, the reason the mole is confusing is because it's used generally to represent atoms. It was devised to be a way of basically allowing chemists to account for the insanely huge number of atoms present in like anything, because there's a lot of atoms and stuff, like a lot. So if you have 1 mole, and again, it's like it's shortened from molecule. It has nothing to do with the little rat creature that digs through yards and you want to like slice in half. I've done that before, not me personally, but like I've had traps that like to chop them. I had to pitchfork one once. It was not the. It was kind of gruesome. I didn't enjoy it. But anyway, besides the point. The mole, in this case, like let's say we have 1 mole of atoms. Well, that's a lot of atoms. 1 mole of something, 1 mole of atoms, that's equal to 6.02 times 10 to the 23rd atoms. That's a crazy big number. All right. And obviously, it's in scientific notation, and I don't want you to freak out and be like, oh, it's in scientific notation, and like, oh, what are we going to do? And it's okay. It's a number. We'll be fine. So we've got our mole of atoms, 6.02 times 10 to the 23rd atoms. And what you're going to do with that, you're basically just going to use that to help you solve a whole bunch of problems. But to just give you a little bit more background on the mole first. So, like, let's say you had a mole of, like, 1 mole of cars. Well, then you would just have 6.02 times 10 to the 23rd cars, which would be ridiculous. I mean, that would be so many cars. It's like this number is so big, it's hard to imagine. On the Canvas side, I'm going to put some examples of like just how big this is. But like to give you an idea though of how small atoms are. So like we got the pen here, right? So this pen has several moles of atoms in it. Several moles. I mean, I don't know the exact composition of it and the exact mass of it and everything, but there are several moles of atoms in this pen. That means it's like, let's say we had 2 moles of something. Well, then it's going to be 6.02 times 10 to the 23rd times 2. I mean, like, if you had 2 dozen, you have 24, right? If you have 2 moles, you have this number times 2. It's crazy. It's really crazy. So it's a huge number. But what it allows us to do is deal with the quantities of, deal with the molar quantity of different elements and compounds. And the point of this, and the reason we deal with this is because, and this is where it gets kind of weird. Like, let's say that I have 1 mole of, say I have 1 mole of oxygen, or no, let's say I have 1 mole of carbon. 1 mole of carbon. So, 1 mole of carbon, all right, it's equal to a couple things. So 1 mole of carbon is equal to, again, 6.02 times 10 to the 23rd carbon atoms. So I'm going to write it like that. I'm going to abbreviate carbon C. At the same time, 1 mole of carbon is also equal to a certain mass. And this is why all this actually matters and why we care about any of this. 1 mole of carbon is equal to 12.01 grams of carbon. Now, how do I know that? Well, this beautiful thing called the periodic table, we know that carbon has an atomic mass, an average atomic mass of 12.01. All right. Now, what that means to us is that the mass of carbon, the mass of a mole of carbon, is 12.01 grams. I know that because the mass of 1 mole of anything is equal to its atomic mass on the periodic table. So, a few things to write here. So in short, important stuff. So 1 mole of anything is equal to 6.02 times 10 to the 23rd. That's a big one. Next, 1 mole is equal to the mass of an element from the periodic table. You can also have a mole of molecules. You can have a mole of formula units, all kinds of different things. So, to give you another example here, let's say we had 1 mole of lithium atoms. And just so you know, from now on, after this little video example, I'm going to be abbreviating mole as MOL. So I'm just going to abbreviate it MOL, not write MOLE. I'm just doing it to try to be like succinct here. But after this, I'll just be writing it MOL. So 1 mole of lithium atoms, it's equal to, again, 6.02 times 10 to the 23rd lithium atoms. But it's also equal to the atomic mass of lithium, which is 6.94 grams. So we'll say 6.94 grams of lithium. And this is important to understand that, like, these numbers on the table, they don't represent grams. They represent atomic mass units. But the mole, the way it works, we found that if you have a mole of something, that's equivalent to the average atomic mass of something in grams on the periodic table. So that's the basic idea. Now, what do we do though if we have a compound? What if we do, like, and this is where we're gonna get to the part where you're gonna be doing stuff here. So what if we have a compound of something where instead of like just lithium, what if we have something like we'll say CH4, so methane. All right, so 1 mole. So what do we say about this? So we would say, all right, let's say we have 1 mole of CH4. So here's an example. If we have 1 mole of CH4, well, we would say that we have 6.02 times 10 to the 23rd molecules of CH4. First thing you're going to notice is that I wrote molecule instead of atoms. That matters now. So if you have a molecule, that is if you have more than one element, all right, that's going to be a molecule. If you have a single element, like carbon, like lithium, then you're going to write atoms. All right, that's a big difference. It's an important thing. Units and detail matters now a lot. So we've got our molecule, so that's cool. Now, the mass. What about the mass of this? Like, what is the mass of this in grams? Well, what you're going to do, you can't just look up CH4 on the periodic table. I'm pretty confident in saying, if you look on here, there's no CH4. But there is C, and there is H. And you can multiply H by 4, and then you can figure out the total mass. So I'm going to show you this example. This is how to find the molar mass of something. So this is called the molar mass of a compound. The molar mass of elements is just look it up off the table. This is the molar mass of compounds. So I'm going to show you this long way of doing this. Once you do this once or twice, it's really easy. It's fast. You're not going to have to worry about this as much. So we got CH4. All right. We want the molar mass of this. So here's what I'm going to do. I'm going to break it down into a little chart for you, which is kind of excessive. But it's like a way of showing you how to do this. So we got our element. So we got our element. Our first element is carbon. Second element in the compound is hydrogen. All right. How many do we have of each? We have one carbon. All right. We have 4 hydrogens. Oh, I forgot. We got to have in here. We just need the mass before we have the total mass. So what is our mass of carbon off the periodic table? So you're going to say it's 12.01. There's carbon's mass. Hydrogen's mass is 1.01, again, off the periodic table. So what you're going to do, you can maybe see how this is going to go here. So 1 times 12, what's that equal? Obviously 12.01. 4 times 1.01 is 4.04. So you're going to multiply these numbers together. So I'll do parentheses there to kind of indicate that. Then you're going to add them up for a grand total final mass of 16.05. So what is the molar mass? What is the mass of 1 mole of CH4? It is 16.05 grams. All right. Your units for this, the actual way you would write units for this type of problem, you would write it grams per mole. What does that mean? It means that for every 16.05 grams, you have 1 mole. That's what it really means. So that's why you write grams over moles. Now, let's do a more difficult one, because there are definitely harder ones. Let's say, what is the molar mass? And because then today, this is just what we're doing. We're just figuring out the mass of these problems. Later, in the next few days, you'll be doing this plus a bunch of other stuff. So it's like, this just becomes part of a problem that you do for a bunch of other things. Today, this Avogadro's number, 6.02 times 10 to the 23rd, that doesn't matter to us really yet. Not yet. We're caring about the mass right now, the grams. Later, we'll care about this. All right. And I get it, this is a little abstract, and like there's not that much context being given for this because it's just the online thing is making that part a little difficult. So just do the best you can. Follow along with the problems. That's what you need to focus on, and you will be fine with it then. So another example 2. Let's say we're going to do iron phosphate, iron 2 phosphate. So there's a formula. So iron, so we got 3 irons, then we got phosphate. Now, the reason I'm showing you this one, let's figure out how much of everything we've got. So we've got iron. Obviously, how many irons do we have? We have 3 irons. Phosphorus. How many phosphorus do we have? So the way this is going to work, this 2 is distributed to both things inside the parentheses. So you can assume there's a 1 here. There's nothing there, so you can just assume there's a 1. So it's basically 2 times 1. So how many phosphoruses do we have? 2. And then how many oxygens do we have? Well, 2 times 4 gives us 8. So the 2 gets distributed to everything. This 2 does not go to iron. Nothing to do. Like this 2 only applies to what is inside the parentheses. It does not apply to iron. So then you're going to look up the masses on the periodic table. So irons is 50. It's 55.85. Phosphorus is 30.97, and oxygens is 16.0. All right, so these numbers are from periodic table. All right, so then you're going to multiply these all together. And get your answer. You'll add it up, and then you'll be done. So I don't know these, I'm going to multiply. So 167. So then once you get that, you're going to add them all up. That'll give you your molar mass of iron phosphate. So that's a grand total of 357.49. And again, we'll write grams per mole. That's the proper term. Again, implying that for every 1 mole of this formula, you have 357.49 grams of it. That's it. So now, your work. What are you doing? This is your work. You're going to find the molar mass of these formulas. All right. First, this is number 1. This is not carbon and iodine, for the love of God. A lot of you are going to do that. Every year. It's like every year. This is the first problem. Everybody thinks it's carbon and iodine. No, it's chlorine. Cl2. So it is chlorine. Chlorine's a diatomic molecule, which we need to talk about. But chlorine is always Cl2. So that's chlorine. So this is pretty much you're just going to say, all right, I got chlorine. I've got 2 of them. Chlorine's mass is 35.45. You multiply it together, you're going to get 70.9 grams per mole. That's number 1. You're going to do the same thing for all of these. Okay, same thing for all of them. You'll go through, you check your answers. As you get to the bottom here, like you'll notice, like for number 12, you see how there's like CH and then C and then OO and then some H. Combine those so that you have, turn this into C2H4O2. All right, just in terms of for mass. This is the way you write the formula for acetic acid. It's the other way you could write is HC2H3O2, or this is the organic way you would write it. But in the end, you can just combine them because then you care about the mass. So when you do that, all right, that's it. So that's how you do molar mass, and that's the basic introduction to the mole. There's also videos that you should be watching about the mole on the website that I posted, and some like reading to look at and stuff. So please check that out too.